Here we have a remote controlled car moving over a horizontal surface, moves in a straight line through a point A. Initially, it's at the point with a displacement 3 meters from A. Its velocity, lowercase v, at time, lowercase t seconds, is defined by this. So part A, find an expression for the displacement, r meters, of the toy from A at time t seconds. In other words, we're given velocity in terms of time. As you can see, velocity is not constant, it depends on t. And we need to find an expression for the displacement, again in terms of t. So the thing we need to know is that if you are given displacement, we're not in this question, but if you were given displacement and you differentiate it, you get velocity. That's because the definition of velocity is the rate of change of displacement. Therefore, if we go the other way and we integrate velocity, we get displacement. Similarly, if we differentiate velocity, we get acceleration. The reason for that is acceleration, by definition, is the rate of change of velocity. Similarly, if we integrate acceleration, that takes us back to velocity. Now, not all these differentiations and integrations are with respect to time. So part A, we've been given velocity, we need to find displacement, so we need to integrate the velocity. So to do that, we're going to integrate 0.06 times brackets 2 plus t minus t squared. To do this, I decided to bring the common factor of 0.06 out to the front of the integral. You can always do that with common factors, and then integrate the three terms. Very important brackets here, and also very important plus c. We've been told that initially at a point with displacement 3 meters from A. So that means when t is nothing, r is 3. This question has asked us to use r for displacement. I know in my diagram I've used s for displacement. Sometimes x is used as well. So don't get confused by that. R here is representing displacement. So when t is nothing, r is 3. Sub those in, and that tells us that c must be 3. So there's our answer for part A. Make sure you write it out in full, including your value of c. Don't just stop once you've found c, you present your final answer. Now I've decided to expand the brackets out. You didn't have to, you could have left it as it was. But since 0.06 could be neatly divided by 2 and neatly divided by 3, I thought I would do it. So there's the answer to part A, 4 marks. In part B, at time 2 seconds, the toy launches a ball which travels directly upwards with initial speed of 3.43 meters per second. Find the time taken for the ball to reach its highest point. So this ball will be moving under the influence of gravity and nothing else. In A-level maths, we ignore air resistance. It's one of our modelling assumptions to make the numbers a little bit simpler. So we don't need to worry about air resistance. It's only moving under the influence of gravity. And since gravity is constant, but the acceleration due to gravity is constant, we can use the constant acceleration equations, also known as the SUVATs. So I'm going to work vertically here. It travels directly upwards. So initial speed 0.43. In actual fact, this ball will be moving like a projectile, like an N shape, but we don't need to worry about that. If we're finding the time for it to reach its highest point, then we can simply work vertically. We don't need to consider the horizontal motion as well. So working vertically, u will be 3.43. Acceleration will be minus g. When it reaches its highest point, it'll have a velocity of 0. At that moment, v will be 0. So using those three values, we want to find t. So v equals u plus at. Sub in your values. For the Edexcel exam board, we use 9.8 for g. If you're doing different exam board, you might use 9.81. But for Edexcel, we use 9.8. So the time taken by rearranging this, 3.43 divided by your value of g, which is 9.8. And since g is a rounded number to 2 sig fig, then our final answer must also be given to 2 sig fig as well. So there it is, 0.35 seconds. Now that's actually 0.35 seconds after the ball was launched.